Good morning, people. So, here's the dealio. Some projects or updates here to motivate y'all to get out there and build things safely and legally. So, first things first. First things first. This right here is a radio. This right here is a cell phone. Hey, beam me up, Scotty. Roger, Roger. Hey, Mom, how you doing? Nope. It's not for that. Although, I wouldn't mind this, though. Dude, I got the world's coolest antenna on my cell phone, man. I got the Mondo reception. We don't need no stinking Verizon. I got a real antenna. Which is removable. Yeah. No, this is a standard 2-meter 440 dual band ham radio, the old as hell, IC T7H from ICOM. This radio picks up the APRS beacons. Let me show you how this works here. I'm going to put it on the Doppler beacon instead for right now, just so you can get an idea. But I want to show you what the ping sounds like. Yeah? Are you dead? Is the battery dead? My call sign. Kilo Golf 6, Lima Sierra Echo. At a very slow rate. Anywho. These are used to help track my rockets. The problem is that simply I have these antenna on and actually, well, aim the antenna, look for a strong signal. Low, high, low, low, high, low, and go. So in that direction, walk that direction. That kind of stuff. It works, but it could be better. Instead, we have something called Packet, or APRS, Automatic Packet Retrieval System, or Reporting System, or very incorrectly known as Automatic Position Reporting System, which is completely not what it is, actually. Although most of the time it is position information, it can be anything, technically. It's a way of transmitting data across multiple hops. So, APRS, or APRS, has this cool functionality. It takes GPS data, the GPS antenna right there yonder, decodes it, then resends it as a string of data off. Oh, pardon me, got a great poupon. It's definitely 8 a.m. off over the airwaves onto a radio. Now, radios pick up this of data, and that's about it, basically. They don't do much else. You have to be able to decode the data. Kind of like a modem works. And that's where this old-ass Android phone comes in handy. So, there is definitely tons of APRS software for Windows. There's some for Mac, Linux. But thankfully, I personally made a product called APRS Droid, or APRS Droid, and that product allows you to run on an Android phone. These things have got plenty of power to do that kind of stuff, like tons, and they're inexpensive, and they're small. So I have an old phone here I've had laying around for quite some time, and I put that phone in the same 3D printed holder, along with a charging jack and 3 18650 cells to power the whole shebang for about 7 hours at a time, in this. So now I've got a completely unified system. Now, normally I wouldn't waste a good ham radio handheld being tied up as a dedicated piece of hardware. But I've got 2 other handhelds. One more of these, and then actually a brand new one. So they're all low-end dual-band radios. They don't have onboard packet or a high-end display or whatnot. But the advantage to using this one's transmit section got burnt out years ago for amateur satellite stuff I was working on. Banging off AO51, I basically blew up the final into the wrong antenna. Oops. So, because of that, they basically become glorified scanners with like 30 milliwatts output. So, they use this as normal ham radio handheld. So, adopted this purpose, no big deal. And actually, these radios are really easy to operate in the field. You can dial in a frequency if you want to on the D-pad directly. So, and there you go. Project number 1 of the last few days. Number 2.
Plutonium space modulator.
Stick 'em up. What this is also part of rocketry, or tracking things too. It is a budget from Harbor Freight Tools personal audio amplification ear device. I just shoved the circuit board inside of here. The remnants of a Halo 4 pistol, heavily modified. And then some all-thread and a microphone. This is a saddle dish I got from Goodwill. So, a little bit of math, found the focal point, tested the focal point out, and now I've got a device. This acts again like a directional antenna, so I can turn to the 3D printer back there and hear that very clearly. I do this, it's half the volume. So I can kind of go, oh, the noise is in that general direction, let's walk in that direction. And that's important because RF works really well for long distances, where ham radio beacons will go a dozen miles easily. But the problem is that when you get really close to them, the signal is so strong going into the radio, you can't really tell which direction you have to go into. This will give you actual location. This is immune to that for the most part. But the old-fashioned just beacons don't have that ability. You have to use some massive attenuators. And even then, the resolution of rotational accuracy is not that good. So this allows me to do smaller rockets that are cheaper to fly, because this is a couple $100. I don't want to lose that. The rocket's worth less than the tracking transmitter is. So from that standpoint, I really like to use acoustic beacons, little beep beep, beep beep, little pingers, so to say, that use a little buzzer inside in my rockets I do for short flights, because they're only going to land if in half a mile anyway, so something really bad happens. And the actual tracking beacon itself is $15 with the battery. If I lose that, well, it's not pennies, but it's a lot less than $300 or $200. So, and also, acoustically speaking, it's a lot easier to use. So, less things that go wrong. It's a microphone and an amplifier, not a whole radio and a cell phone. So, there you go. My recent two little projects.